Okay, let's jump back in and finish up section 7.5. Before our 2-week spring break, we defined the 3 inverse trig functions as follows. You have this in your notes from the last class meeting. And we said that when we are evaluating an inverse trig function, we are actually finding an angle. For example, let's just do a quick review. If I say I want to know what's the inverse sine of -1/2, okay, that means that I need an angle, okay, an angle whose sine is 1/2. So we're saying the sine of some angle that I don't know is -1/2. Okay, and we put restrictions on this angle. We said that the domain, -1 to 1, this is in that interval, and the range would be my output or my angle. So I have to give an angle in this interval. Okay, so if we're at, we know pi over 6, the sine is 1/2, so it has to be negative, so we say that it is -1/2. So, whoops, the inverse sine of -1/2 is -pi over 6. So we have to make sure when we're evaluating this inverse sine, we give the proper angle and the proper interval, because there's for one input, there's exactly one output. Okay, so now we're going to ramp it up a bit, and we're going to do compositions. So we're going to go back to using the unit circle to find function values, and then using part of the unit circle to evaluate inverse trig functions. Okay, so what we want to find in part A is we're saying the inverse cosine of the sine of pi. Okay, so a composition. What do? We start on the inside first. So we're trying to evaluate this and give an exact value. Yes, you could punch that in a calculator, but we want our exact value. So we start on the inside. So the sine of pi. Looking at your unit circle, sine is the y coordinate, so that is going to be 0. And now we're saying, what's the inverse cosine of 0? All right, so this here, remember, is a number. It's a function value. Here, we're giving an angle. All right, so inverse cosine. If you look at your little circles, cosine, remember, is in quadrants 1 and 2. So we're giving an angle in quadrant 1 or 2 whose cosine is 0. Remember, the cosine is the x coordinate. So we're talking about up here. Okay. So an angle between 0 and 180, or 0 and pi, that has a cosine of 0 would be pi over 2. All right, let's do this one. Sine of 5 pi over 3. Okay, so we're trying to find what is the sine of 5 pi over 3. What's the y coordinate of that point on the unit circle, which happens to be negative square root of 3 over 2. All right, and then we're saying, okay, what's the inverse sine of negative square root of 3 over 2? So we're talking about an angle in quadrant 1 or quadrant 4 whose sine is negative square root of 3 over 2. Negative means we're talking quadrant 4. So it's going to be a pi over 3 reference angle. So it's going to be negative pi over 3. All right. We're on a roll now. Okay, here we go. Another one. Inside, what's the cosine of pi over 6? Okay, cosine of pi over 6 is square root of 3 over 2. And then we're saying, okay, whoops, I don't quit touching that, sorry. What's the inverse? It's touchy. What's the inverse cosine of square root of 3 over 2? So give me an angle between 0 and pi, whose cosine is square root of 3 over 2. Well, cosine is positive in quadrant 1, and that would be pi over 6. So look what happened. We did the cosine of pi over 6, we found that value, and then we turned around and said, what's the angle that has that cosine? Okay, so basically remember inverse functions, one undoes the other, and this is that perfect situation where our input, we ran it through both functions and it comes out being the exact same value. So tangent of 7 pi over 6. All right, where's 7 pi over 6? That's located in quadrant 3. Tangent would be pi over 6, the tangent values would be 1 over the square root of 3 or square root of 3, over 3. And in that quadrant, tangent is, positive, yes. Okay, so it doesn't matter which version you use, if you use square root of 3 over 3 or the other. Okay, then we say, okay, what's the inverse tangent of square root of 3 over 3? What's an angle in quadrant 1? Because inverse tangent is positive, that's quadrant 1. Whose tangent is square root of 3 over 3? Well, that's going to be pi over 6. So notice how one did not undo the other. We started with 7 pi over 6, but we ended with pi over 6. And that the reason one didn't undo the other is because 7 pi over 6 is not in the range of inverse tangent. The range of inverse tangent, remember, is negative pi over 2 to pi over 2. Okay, so continuing on with some compositions, but now they're not exact values that we know or where we can use our unit circle. So once again, we're asking for an exact value without using a calculator. So I'm saying, what's the tangent of the arc sine of 2/3? So if you remember, arc sine is the same thing as inverse sine. Okay, so here's the deal. I don't know the angle whose sine is 2/3. That's not a unit circle angle. So to get an exact value, we're going to have to set up our reference triangle to represent that angle. So I'm going to call that angle theta. Okay, so theta is the inverse sine of 2/3, then that means theta is an angle whose sine is 2/3. Because that value is positive, means we are in quadrant 1. Okay, so that angle theta is in quadrant 1. And we can set up our reference triangle using our point on the terminal side definition. So remember, sine is y over r. All right, so we can label our triangle accordingly. That y, this is 2. R is the distance to that point on the terminal side. So it's the hypotenuse, basically. And now we can say, okay, well, what are we ultimately trying to find? We're trying to find the tangent of this angle theta that we've drawn over here. Okay, so what do we need for tangent? We need, tangent, remember, is y over x. So I need the x coordinate, which we can then come up with from Pythagorean theorem. So x squared plus 2 squared is 3 squared. All right, and since we're in quadrant 1, we choose the positive root. So x is the positive square root of 5. Therefore, we get the tangent of theta to be, what's y? Y is 2 over the square root of 5, or 2 square roots of 5 over 5. Now, you check it. Put this in your calculator. If you put the left side in your calculator and the right side in your calculator, those should come out to be the same. All right, let's do another one. We've got a little something else going on in here, though. We got to pay attention. Okay, so I'm saying, what's the sign of, here's what we did not have in the last example. 2 times the inverse cosine of -1/9. Okay, now, I don't know about you, but I don't know what the inverse cosine of -1/9 is. I don't know that angle, so I'm just going to call it theta. All right, so ultimately, what am I trying to find? I'm trying to find the sine of 2 theta. Oh, okay. Well, I have an identity that helps me find the sine of twice of an angle, or twice an angle, which means I need to take 2 times the sine of theta times the cosine of theta. All right, well, I know theta is the inverse cosine of -1/9, which means the cosine of theta is -1/9. Okay, we're talking cosine, negative. Inverse cosine is defined in quadrant, or would be in quadrant 2. So theta is in quadrant 2. And I know that cosine is x over r. So I have got x is -1 and r is 9. Okay, so here's theta. I know the cosine of theta, so I'm good. I know cosine of theta here is -1/9. So to evaluate this, I now need the sine of theta. So for sine of theta, I need y over r. So y, I need to find y. Once again, Pythagorean theorem. And I know that y is positive in quadrant 2. So y is the positive square root of 80, which we should be simplifying that radical. So that comes out to be 80 is 16, so that'd be 4 square roots of 5. So sine of theta is then 4 square roots of 5, y, and r is 9. So I come back over here and I fill that in, and then I multiply. And that's 2 over 1. And I can only multiply 2 things at once, so you choose what that is. I usually do these two myself. So this becomes 81 on the bottom, and that would be -4 square roots of 5 on top, times 2 would be -8 square roots of 5 over 81. And once again, punch that in your calculator. That should be equal to this value. Okay, now each time we just get a little more going on. So this one has more going on inside. So I'm saying, what's the cosine of the sum of two angles? Inverse tangent of -5/8 and inverse tangent of 4/3. So basically, those are two different angles. So I'm going to call this one A, and I'm going to call this one B. So basically, you can see then I'm saying, what's the cosine of A plus B? So it's a cosine of a sum of two angles. Okay, we've got an identity for that. Do you remember the pattern? Cosine, cosine, sine, sine. And these are opposite. If this is a plus, this is a minus. Okay, so I want you to pause the video, and I want you to come up with the sine and the cosine of angle A and the sine and the cosine of angle B. So we'll set it. Okay, tangent is y over x. So I can label my triangle -5 over 18. And then when you find r, you would get square root of 349. And then, so that gives us cosine of A is going to be 18 over the square root of 349. No need to rationalize. Do not make a lot of effort doing that until at least the end when you know you really, really need to. And then the sine of A would be -5 over the square root of 349. Okay, so B is, this is 4, this is 3, this is a 3, 4, 5 triangle. Nice. So cosine is x over r and sine is y over r. Okay, and then you just substitute into the formula. And then multiply and subtract. Okay, so when you plug in the values, you multiply, you simplify, you rationalize. Here's what you get. Either of these. My math lab, of course, will want you to rationalize.